Welcome to lesson number 5, charge flow. Keywords for this lesson are coulomb, charge and current. The key question for this lesson is, how do you define electric charge and current? Have a go at the first knowledge check. Once you've done that, come back and we'll check the answers together. Come back, let's have a go at the first knowledge check. Question number 1, state the particles in the atom that carry charge, electrons. Question number 2, state the two types of charge, positive and negative. Question number 3, do like charges attract or repel? Repel. Do unlike charges attract or repel? Attract. How can a static charge be created on an object? By rubbing. Which type of material cannot be charged? Metal. How does a material become positively charged? Loses electrons. How does a material become negatively charged? Gains electrons. Overview for this lesson. Describe electric charge and current. Recall and use the equation for electric charge. Before we get started, I'm just going to remind you of the atom. An atom is made up of 3 particles: electrons, protons and neutrons. The electrons go around the central part, which is called the nucleus, and electrons orbit in shells. And then in the center we have the nucleus, and that's made up of protons and neutrons. Electrons are negative, protons are positive, and neutrons are neutral, so they have no charge. So atoms are neutral, and that means the number of electrons must equal the number of protons. So if we have one electron, we must have 1 proton. The charges cancel each other out. If we have 2 electrons, we should have 2 protons. They cancel each other out. Now, we can charge atoms and form what we call ions. And we do that, we form ions or charged particles or charged atoms by changing the number of electrons. We never change the number of protons. If you change the number of protons, you get a different atom. So if we add electrons, so if you start off with 1 electron and you add an electron, you have more electrons than protons. So what you have is a negative ion. If you have less electrons, so if I remove an electron, so I have no electrons and 1 positive charge, the ion then becomes positive, or the atom becomes positive, and it forms a positive ion. So we can remove electrons and add electrons to make either negative or positive ions. Electric charge. The word electricity comes from the Greek word electron, meaning amber, and refers to amber's attractive properties. What the Greeks noticed was that when you rub amber, it becomes charged, and if you hold it against, becomes charged when you rub it. And when you hold it against dust or hair, it starts attracting the dust or the hair, or any other object which is light. But what is electricity? If we answer this question, we mostly come up with answers which describe what electricity does. For example, powers lamps and motors. But like most of the concepts we have studied so far, we need to look deeper into the fundamental nature of the problem to gain an understanding. We need to start by examining the nature of matter. Matter is made up of particles. The smallest independent particle is the atom. Atoms are made up of protons, neutrons and electrons. To explain electricity, we only need to talk about protons. To explain electricity, only need to know about protons and neutrons, protons and electrons, because the neutrons are neutral. There are 2 types of charges, positive and negative. Protons have positive charge, electrons have negative charge. And when we talk about the smallest independent particle being the atom. I know electrons and protons are smaller, but the independent particle we mean stable. If you were to have electrons by themselves or protons by themselves, they're unstable. They will attach themselves to something else. Again, the reason we don't need to deal with neutrons is because they're not charged. And essentially, we're talking about here electric charge. So, electric current in a circuit. Electric current is a movement or flow of electric charges. So, electric current is a flow or movement of electric charges. So, for example, if we have a wire here and we put a potential difference across the wire, a voltage, and we can cause the electrons, the negative charges inside the wire, to begin to flow. This in most cases is electrons, movement of electrons in most cases. It can be other charged particles as well, but in wires and in most circuits it's electrons which move. A simple circuit is basically a loop through which the movement of electrons occurs. So basically a simple circuit is basically a loop through which electrons can flow. A simple circuit has power source, for example a battery, and the battery provides a voltage or a push. So it provides a voltage, and the voltage is the push. So the electrons require some source of energy to get them moving, and that's provided by the battery. Remember, the battery generally are chemical stores. So remember, they don't store electrons as such. They are chemical stores, and it's the chemistry that provides the push once we connect the circuit up. A copper wire or any conductor is required for electrons to flow around the bulb, or basically any other component that you want to put in. And when we talk about electrons or something else, we are talking about resistance. And to overcome the resistance, you need to do work. Electric current is the flow of electric charge around the loop. So again, electric current is the flow of electric charge around the loop. In this case, this circuit will light the bulb. So remember, when we talk about electricity, what we're talking about is the pathway is electrical. And it's taking it from the chemical store inside the battery to, in this example, bulb, the thermal store in the bulb, and that produces the light that we see, and it heats the bulb up. So remember, we can link it to energy stores that we've already come across before. And the reason we use copper wire, it's a good conductor, but remember, it's also expensive as well. So here we have a diagram of a simple circuit, and I'm just going to draw in the wire because it's not too clear. So here we have the copper wire. Here we have the battery. This provides the voltage or the push. And remember, it's usually a chemical store. The copper wire. Remember, electrons are, we're not creating electrons. Electrons are in the wire, and when we provide a potential difference across the battery terminals when we connect it up. All we're doing is pushing the electrons around this loop. So if you take your finger and you put your finger on one end of the battery, one end terminal, what you'll find is there is one loop. If there is no loops, no electricity can flow, or no electrons can flow. So this is the loop, and the electrons flow around the loop as well. So here we have the bulb, and the bulb adds a resistance. So this is a resistance. It resists the electron, so we have to do work. And if it's useful work in the form of bulbs, it will give off light. So we're moving from a chemical store to a thermal store in the bulb. When we heat the bulb up, or the filament, it gives off light. One of the things that we need to be able to do is calculate electric charge. Electric charge can be calculated with the following equation. Charge flow equals current times time. And in symbols, charge is Q, current is I, and time is T. Remember, when we do physics and science, the symbols are not always obvious from the equations, or word equations. And the reason is that a lot of this here, the symbols actually come from different languages. And so charge can mean something else in a different language, and we just adapted that to use in physics. So charge flow, Q, or charge, is measured in a unit called a coulomb, and its symbol is C. Electric current I is measured in amperes, or amps for short, and its symbol is A. And time, T, is measured in seconds. So these are the standard units. So whenever we do calculations, we always need to make sure that we're working in these standard units. So we have an example here. Charge work example. What charge is delivered when if a 20 amp current flows for 5 seconds? So we always start off, the way I like to start these questions off is write down what we know, so the variables, and what we don't know. And note, this is a 3 variable problem. There's 3 things here. We need to know 2 of them. So if we need to work out the charge, we need to know the current and the time. So do we know the current? Yes, we do. 20 amps. It's in the right unit. Do we know the time? Yep, 5 seconds. Do we know the charge? No, we don't know the charge. Do we know an equation that links charge, current and time? Yes, we do, over there. So what we need to do then is just substitute the values in. So we put, for I, we put 20 amps. For time, we put 5 seconds. Multiply out, do the maths, and we end up with 100. Remember to always add the unit, so 100 coulombs. You also need to be able to rearrange this equation as well. So we kind of looked at rearranging in the last question as well, in the last topic, sorry. But for now, what we've done is just given you the 3 equations. So in equation number 1, if they ask you to work out charge, you need to know the current and the time. If they ask you to work out the current, you need to know the charge and the time. If they ask you to work out the time in the equation, you need to know the charge and the current. So there's 3 equations, and you should know these 3 equations, or use the 3 equations. Have a go at the first task. It's fairly straightforward. We need to work out the charge. So remember, to calculate the charge, we have to multiply the current and the time. So we've given the current and we're given the time. So for example, the first one, work out the charge. Remember, we need to multiply these 2 together. 20 times 5, which is 100. You don't need to write coulombs after it because it's given you in the heading coulombs. Have a go at the rest, come back and we'll check the answers. So let's fill in the rest of the table. So charge in the second one is 2 times 3, which is 6. So current times time. For the third one, current 15 times the time, 4. That gives you 60 coulombs. Current for the fourth row is 10, and the time it flows for is 4 seconds. So that's 40 coulombs. Current for the last one is 2.5 and the time it flows for is 2 seconds, so that gives you 5 coulombs. I'm just going to clarify another point. What does this equation actually mean? So I've rearranged it and I've written it as current equals charge divided by time. So each of these electrons has a charge, and if I just say this is a point A on the wire, and current is the flow of charge, so what we do is we fix the time, so let's say 1 second. How much charge flows past this point A in 1 second? That's what the current is. How much charge flows through in a given time, and that given time is 1 second. So how many electrons essentially go past this point in 1 second? And we're not interested in the number of electrons, we're actually interested in the charge on the electrons. Okay, now have a go at the word equations as well. You might have to use the rearrangement equations to answer the questions as well. So have a go at the word equations and the rearranging equations over here by yourselves. You can use your student page. Once you've done that, come back and we'll check the answers together. So let's go through the answers to these questions. So first question is calculate the charge if 4 amps flows for 20 seconds. Now always start off, write down the variable. So what do we know? It's asking us to work out the charge, so we don't know that. We know the current I, which is 4 amps, and we know the time, which is 20 seconds. Do we have an equation that links them? Yes, Q equals I times T. So all we need to do is substitute in the values. So it's 4 times 20, which is 80 coulombs. So always remember to write the unit as well. Again, same thing. Calculate the charge of 3 amps flows for 1 minute. Now notice this is not the standard time, it's not in seconds, so we need to convert that as well. So charge is what we are asked to calculate, so we don't know that. Do we know the current? Yes, 3 amps. Do we know the time? Yes, it's 1 minute, but we need to convert that time, 1 minute to seconds, which is therefore 60 seconds. Do we have an equation that links these 3 variables? Yes, we do. Q equals I times T. Substitute in the values, 3 times 60, and that's equal to 180. Remember to add the units, coulombs. Question number 3, very similar as well. So again, Q, I, T. So it tells you in the question is a series circuit has 2 bulbs and a current of 5 amps. What charge flows through the bulbs in 20 seconds? So we know the current is 5 amps. We don't know the charge, and we know it goes for 20 seconds. We have an equation that links them. Q equals I, T. So 5 times 20 is 100 coulombs. Next one. The heating element of a kettle draws 8 amps of current. How much charge has flowed through it if it takes 120 seconds to boil? So again, Q, we don't know the charge. I, 8 amps. T is 120 seconds. Q equals I, T. So I is 8, time is 120. Remember here, this is a little bit more difficult mathematical question. Always use your calculator. Okay, you will be allowed in calculator, so use your calculator. You can do it in your head. If you do it in your head, always check your answer using your calculator as well. Now, last question here. A 25 watt LED light is left on for 1 hour. So it tells you the time. 1 hour is 3,600 seconds. That's a good thing to remember. How many seconds are in an hour? How many seconds are in a minute? It's used a current of 0.1 amps. What charge flows through it in this time? So they're just asking you a charge question again here. Q, I, T. You don't need the watts part. That's just an extra piece of information that you don't need. So current is 0.1 amps. We don't know the charge. Time is 3,600 seconds. Do we have an equation that links you through variables? Yes, Q equals I times T. Notice I put IT next to each other as well. Whenever we have two letters next to each other, it means that I times T. So I is 0.1 times is 3,600, and if you put that in your calculator you'll get 360 coulombs. Now this table is slightly different. Best thing to do is when you work out the table here, the answers, either do the working on this side or on the students page. So here it's asking you to work out the time. So you have to pick the right equation to work out the time out of the three equations that we were given a bit earlier. So I'm just going to find those equations and just remind you what they are. So here are the equations. So you pick the right equation. So they're asking you to work out the time. We need to know the charge and we need to know the current. So to work out the time, we divide the charge by the current. So if you do that, you'll get an answer of 5. So charge divided by the current gives us a time of 5 seconds. Again, for the second one, it's asking you to work out the current. So you need to go back, have a look at your equations and pick which one. In this case, it's the second one, and that's charge divided by time. So we divide the charge by the time, so 6 divided by 2, and that gives us 2. For the third one, it's asking us again to work out the time, so we use equation number 3 here. So when you do the calculations, you'll work out that's 4. So I'm just going to fill in the answers. You can have a go at the rest yourself. Just pick the right equation out of the 3 equations that we have and check your answers with mine. So now have a go at the rearranging equations in word format. Again, have a go at the extension questions as well. Once you've had a go at that, come back and we'll go through the answers together. So let's go through the answers of rearranging the word equations as well. So what charge passes if a current of 4 amp flows for 20 seconds? Again, write down your variables over here. Current 4 amps. Time 20 seconds, charge we don't know. We have an equation that links them, and then what we do is substitute the values in. Current 4 times the time 20 gives us an answer of 80 coulombs. Question number 2, what charge flows if 100 coulombs passes in 10 seconds? So again, it's asking us to work out the charge. So write down, what current flows. So this time it's asking us to work out the current. So write out your variables. Charge equals 100 coulombs. Current we don't know, and the time is 10 seconds. Now you pick the right equation, or rearrange the equation here. Q equals IT. Pick the right equation. I, the current, equals charge divided by time. Substitute in the values. So 100 coulombs divided by 10 seconds gives us 10 amps. Question number 3, what charge passes if 2 amps flows for 2 minutes? Again, write out the variables. We don't know the charge, so we put a question mark next to that. The current is 2 amps. The time is not in the standard format, so we need to convert 2 minutes into seconds. So 2 times 60 gives us 120 seconds. And the charge is equal to current times time. Substitute in the values and we get 240 coulombs. Question number 4, calculate the charge flow in 60 seconds in a wire when the current in in the wire is 3 amps. So again, it's asking us to work out the charge. So we don't know what the charge is. We know what the current is, it's 3 amps. We know what the time is, 60 seconds. We have an equation that links the three variables together. So we substitute in the values. 3 times 60 gives us 160 coulombs. Question number 5. Calculate the time taken for 80 coulombs of charge to flow through a wire when the current in the wire is 5 amps. So again, write out the variables. Charge is 80 coulombs, current is 5 amps. Time is, we don't know. Okay, that's what we need to calculate. Do we have an equation that links the three variables? We then rearrange the equation to the right format. So time is equal to charge divided by current. Substitute in the values. So 80 coulombs divided by 5 seconds will give us divided by 5 amps will give us 16 seconds. Question number 6. Calculate the current when 1200 coulombs of charge flows through a wire in 200 seconds. Again, write down the variables. The charge is 1200 coulombs. Current, we don't know. Time is equal to 200 seconds. Our standard equation is Q equals IT, but we need to rearrange this to have the right format. So the current is equal to charge divided by time. So it's 1200 coulombs divided by 200 seconds, which gives us 6 amps. Check your answers. Make sure that you understand how we've gone through. If you don't understand, then replay the video and have a go yourself. So now let's have a go at the extension questions as well. The current in a wire is 0.72 amps. Calculate the charge that passes through the wire in 4 seconds. So again, write out the variables. We don't know what the charge is. The current is 0.72 amps. The time is 4 seconds. Do we have an equation that links the three variables? Yes, we do. So you then substitute the values into the equation as well. In this case, plug it into your calculator because it's not straightforward, and you get 2.88 coulombs. Check your answer on that one. So part B, question 1. Calculate the average current in a wire if a charge of 3,500 coulomb passes in 200 seconds. Again, write out the variables. Q, charge equals 3,500 coulombs. Current, we don't know. Time is 200 seconds. Do we have an equation that links the three variables? Q equals IT. We then need to rearrange this to give us the correct format. So current equals to charge divided by time. Substitute in the values and you should get 17.5 amps for the current. Question number 2. What is the average current in a wire when a charge of 115 coulombs passes in 30 seconds? So write out the variables. Charge equals 150 coulombs. We don't know what the current is. The time is 30 seconds. We have an equation that links the three variables. We need to rearrange that equation to give us the correct format. So we need to have it in terms of current. Substitute in the values and you'll have 150 coulombs divided by 30 seconds, and that will give you 5 amps. Question number 3. Calculate how long it takes for the following charges to pass a point in the circuit. So again, question 3 part A. 6 coulomb flows when the current is 0.5 amps. Now what they're asking you for here is time, how long it takes. So sometimes these questions are not as clear. Sometimes they won't ask you directly for time. They might ask you something like how long does it take. But again, we do it in the same way that we do all the other questions. We write out the variables. So the charge is 6 coulombs. The current is 0.5 amps and the time is what we don't know. So we have an equation that links them. We rearrange the equation for time. Time equals charge divided by current. Substitute in the values. 6 divided by 0.5 and that will give us 12 seconds. For part B, 48 coulombs when the current is 36 milliamps. Now, you got to remember that milli means divide by 1,000. So we need to divide this by 1,000. because it's not in amps, we need to have this value in amps. So this makes this question a little bit more difficult. So question, we know what the charge is. We know what the current is, 3.6 milliamps, but we need to convert that into amps. So what we do is we divide that by 1000 and it gives us 0.036 amps. Time is what we need to calculate. We have an equation that links the three variables. We rearrange the equation to the right format. So 48 coulombs divided by 0.036, and that gives us 1333 seconds for the time. Question number 4. In a lightning flash, a typical amount of charge which reaches the earth is 10 coulombs. If the flash lasts for 0.50 milliseconds, note this is not in seconds, it's milliseconds, the M stands for milli, what is the average current? So again, we do the same thing. So charge is 10 coulombs, current is what we don't know, so we write that with a question mark. The time is 0.5 milliseconds, we need to convert that into seconds. So we divide by 1000 and that becomes 0.0005 seconds. Now we have an equation that links the three variables together. Charge equals current times time. We need to rearrange this so that we can work out the current. So current equals charge divided by time. You substitute in the values and you will get 20,000 amps. And if you don't understand any of the equations or how they're done, replay the video, have a go, and you need to practice. One of the things with equations is practice. Eventually you will get it. If you don't get it, come and see me and we'll work through these examples together. Finally, we need to go through the last knowledge check. So have a go at the last knowledge check, then come back and we'll check the answers together. Come back, let's check the answers to the last knowledge check. Question 1, identify the symbol for electric charge. So the symbol is Q. Identify the symbol for the unit of current. So the symbol for the unit of current is actually A. Rearrange Q equals IT to make I the subject. So when we rearrange this, I equals Q divided by T. Rearrange Q equals IT to make T the subject of the formula. So T is equal to Q divided by I. Name the unit of electric charge. It's a coulomb. Draw the symbol for a resistor. It's a rectangular box. Compare the current in different parts of a series circuit. The current is the same in all parts of a series circuit. Name the unit for current. The unit for current is the ampere, or short amp. Check your answers, give yourself a score on the side.